All right, in this lesson, we're going to be talking about function rules, tables, and graphs. And what I mean by that is we are going to be talking about how to graph some of these functions that don't look like the typical functions we've been dealing with in the past. Okay, so the first thing we need to talk about is there are two vocabulary words um, in this particular section that are really important to know about. These two vocabulary words are independent variables and dependent variables. Okay? Independent variables are the variables that go along the x-axis. We also call these x's, inputs, different things like, there's some other words, we'll go over that in a second. Okay? And then we also have the dependents. Okay, the dependents. These are along the y-axis, or they're the outputs. Okay, so depending on what our input is, we then can find our dependent. Okay, and when we put these two variables together, they become a function. All right, so let's just go over. I know we're putting a lot of different words out there to represent the same thing, so we're going to go through and just uh, do a little exercise to go over what independent variables versus dependent variables are. Okay, so the easiest is we know x and y. The x values are independent variables, and the y values are dependent variables. Okay, and in the last few days, we've been talking a lot about inputs and outputs, as well as domains and ranges. Okay, domains and ranges. Domain, as you learned yesterday, is the same as x, okay, which is the same as independent. Range is the same as the y values, which are the same as the dependents. Okay, so we can use this with some other vocabulary words. These oftentimes are used when writing word problems. They're also good language arts words that are used when you're talking about a story or something that happens, and it can relate directly back to math in this particular situation. So we have our before, which then our after depends on what happens before, and then we have our cause. Whatever cause happens, our effect happens. Okay, so whatever cause and effect. Okay. So what kind of relationships do these variables have to each other? Well, they're one-to-one. So for every x, there's only one y value. And we learned a lot about that when we were mapping our functions. We cannot have, an x cannot have multiple y values. An x can only have one y value. Okay? All right, so we can use this to actually graph some functions. Now, these functions look a little bit complicated or different from the normal things we would be graphing in a coordinate plane. We're really used to seeing, y equals mx plus b type situations. Now we're going into a whole nother realm. We actually have y equals the absolute value of x plus 1. All right, so we have 3 steps that we can use to actually plot these points and make it really easy on us, and it's a foolproof way to do this. Okay, so our first one is to choose inputs for x and then evaluate to find y. And by evaluate, I mean solve. Okay, I mean solve. So if I have my x's, or my independent variables, okay, and then I have my y's, or my dependent variables, okay? And then I have this function, which is the absolute value of x plus 1, okay? So I'm just going to choose, I always, as a rule of thumb, always choose some negative numbers, 0, and then some positive numbers. It's a good balance. It also gets your function across a greater area of your coordinate plane. That way your function doesn't look lopsided, or it's just on this particular side or in this one coordinate, or this one quadrant and things like that, okay? So I'm just going to, for easy sake, I'm going to use -3, -1, 0, 1, and 3. And it is very common for people to just choose those. Not only does it make the actual math easier, but then when you're graphing, you're not having to graph like 25, which is going to be, way up out of my screen. You can't even see it, okay? So from here, I'm actually going to plug my different x's into my function. So I'm going to find the absolute value of -3 and add 1. The absolute value of -3 is 3 plus 1 is 4. And you can do that all the way down. Okay, solve it all the way down. That's why I have this middle column here. So find the absolute value of -1 plus 1 is going to be 2. Absolute value of 0 is 0 plus 1 is 1. The absolute value of 1, 1. Just go down all the way until we have all of our outputs or our y's. So from here we can actually go through and we can actually graph these particular coordinate points that we just found. So we now have coordinate points 3, -3, 4, -1, 2, and so on and so forth. I'm not going to write them all down. You guys can see what I'm doing here. Okay, so I'm going to go through and graph these. So I'm going to go -3, 4, -1, 2, 0, 1, 1, 2, and 3, 4. Draw my lines, which is my now third step I just plotted, which is my second step. Third step is to connect my points to create the function. Don't forget to add your arrows at the end of your function. And we now have, well, in my case, a very lopsided V, but a V nonetheless, okay? Which is actually just a good point to let you know and to think about and kind of commit to memory. All absolute value functions are going to look like V's, okay? So good little side note to know how to do. All right, so the next one we have is, I'll just rewrite it. I know sometimes computer math talk isn't the best. So we have x squared plus 1 equals f of x. All right, and we can actually go through these 3 steps again using this particular function. So I'm going to let you go through, and in your whisk, I want you to figure out your inputs, figure out what your outputs are, graph the function, and then I want you in your notes to actually tell me what shape do we get. What shape is our function going to look like? And I will check it tomorrow. All right? So please make sure that you remember those 3 steps and do this one for homework, and write down any questions if you're totally stuck on how to do this. Otherwise, we will work on this tomorrow.